Hi everyone, welcome to the Production Site Emissions Inventory Guidance video. My name is Mark Gilbert. I work with the Emission Inventory section of the Wyoming Department of Environmental Quality, and today we'll be talking about oil and gas production sites and how to populate the emission inventory workbooks, how the workbooks function, and how to address any issues you may run into. So first we'll go over the contacts. The Air Emissions Supervisor is Tyler Ward. He's the head of our group. And then the Emission Inventory Program Principals are myself, Mark Gilbert, and Ryan Beavers. And the Emission Inventory and Smoke Management Analyst is Nathan McNamara. If you have any questions related to populating these emission inventory workbooks or emission inventories in general, please reach out to me, Mark, or Ryan. And then if you have any questions about impact or the profiles within impact, please reach out to the Impact Technical Support email address, which is below at deq-air-impact@wyo.gov. So the production workbooks, the division generates the new production emission inventory or EI files by pulling emission unit data from impact or using some standard assumptions. Based on the operating parameters returned for these units, the division will calculate emissions for each facility. This includes running a ProMax model for the tanks, dehydration units, and truck loading emissions. So the types of facilities we have. Emission unit data is pulled into the production EI for the following facility types in impact. We have single well routed to pad/central gathering, pad/central gathering, dehydration, storage tank battery, and pipeline station. All other oil and gas related EIs must be reported directly in impact or by using the compressor station pipeline workbook. And if you need help finding that workbook, it's on our website, or Ryan and I can send that to you as well. So the production EI is used to calculate emissions from the following sources. We have engines, heaters, tanks, glycol dehydrators, desiccant dehydrators, pneumatics, flares, fugitives, venting, pigging, and blowdowns, workovers and completions, truck loading, non-road mobile, and on-road mobile. And we'll go into further detail on those in a minute. So here's an example of a facility profile that would get pulled into a production EI workbook. As you can see, it is a pad/central gathering facility. And so there's a lot of information within the impact profile that will get pulled into these workbooks. One example is the facility information. We will have that it is a pad/central gathering facility and the facility name with the facility ID. And of course, the correct owners and if it is currently operating or not. And if it's not operating, it will not get pulled into the workbook if it did not operate at all during the reporting period. So the location gets pulled into the workbook, and that's where we get our ambient data from for temperatures and solar insolation and wind speed. So please ensure that these are correct. Along with this, the API numbers will get pulled in. So all 120 of these API numbers will get pulled into the workbook for that specific facility, and we will sum up all of the WOGCC production data for that reporting period. Now, let's look at some of the EU parameters. So we will expand the facility tree here and go down to Tank 1. Looking at Tank 1, there's several things that will get pulled into the workbook. The descriptions, the company ID, and the AQD ID. And as long as the construction dates line up, if operation commenced during or prior to the reporting period, it will get pulled into the workbook. And we want to ensure that this says operating. And we will also pull in the capacity of the tank. So 400 barrels, that will come into the workbook as 400 barrels. And then to release point. Well, let's talk about the control first, actually. So this tank actually has a control on it, and it is a flare. So because it's a flare, it will pop up in the workbook as a flare controlled tank. So under the controls for that, the control column on the tank sheet, it will list a flare as the control. And With that, we assume that all flare controls are 98% within the workbook, so the control efficiencies down here do not dictate the emissions for the tank. We will assume a 98% control efficiency and 98% operating control efficiency for that tank if it has a flare on it. And then we'll look at the release point. So we will use the release point data for the point source emissions from this emission unit. And because it's vertical, it will be listed as a point source. And this will also occur with the horizontal type. So there's VER and HOR for vertical and horizontal. Those will both be point source. If there is an AVL on the end of it, for example, look at the fugitives here. Fugitive emission unit has an area release point. So as you can see, fugitive. So this will come into our impact EI report as a fugitive source instead of a point source. So as you can see, the facility profile definitely has a huge effect on the workbooks. So please ensure that everything in your facility profiles are correct so that when we create the workbook, it will be as accurate as possible. And that way, in future iterations, you have minimum work to do on that end, and everything should come through as accurately as possible. So now that we've gone over the basics of a impact facility profile, let's talk about what to do if we are missing critical information from impact. So first, missing emission units cannot be manually added to the production EI files since the division would not have the corresponding emission unit and process IDs in which to store the emissions when the division receives the files back. For example, if a, say, single well has a flare associated with it, well, if you add that flare to the workbook and it's not an impact, when we receive the emissions from that flare, there's nowhere to store it in impact because we don't have a flare associated with that facility. So we would need to get that flare added to the facility first. So if emission units are missing, the impact facility profile will need to be updated, then a new version of the production EI file can be generated and sent back out. If entire facility records are missing from the production EI file, please inform the emission inventory section immediately. The facility may already exist in impact and an ownership change is required. Alternatively, a new facility profile may need to be created. Operating hours. For the annual emissions inventory, the maximum operating hours for any emission unit is 8,760 hours. For a leap year, it's 8,784 hours. For the winter emissions inventory, the maximum operating hours for any emission unit is 1,416 hours. And for a leap year, it's 1,440 hours. So for any given report, the hours of operation cannot exceed the numbers listed here. And then submitting the emissions inventory. When the emission inventory form is complete, please email it back to the original sender. The original sender's email should end with @wyo.gov. Now, the section that follows contains instructions pertaining to the information needed on each worksheet. Carefully read the instructions and report the parameters and emissions accordingly. Not all oil and gas facilities are identical, so please call the emission inventory section for any help with any questions. All right, so here is an example of one of our 2023 annual EI production workbooks. This is the facility summary sheet. So first I'll start off with the cell coloring on here. So the cell color and text combination within the production EI file provides guidance as to the inputs requested or needed from the operators. So the gray cells are either headers or contain data extracted from impact which cannot be changed. If any of these gray cells contain incorrect data, please inform the emission inventory section immediately so the division can update the information in impact and generate a revised production EI file. So for example, if I go to the extended hydrocarbon analysis sheet and I try to update the facility name, this cell is protected. So once again, just contact us if any of this information needs to be changed. We'll update impact and then regenerate the workbook and send it to you. Then there are the blue and orange cells that contain data that need to be verified or populated if blank. If there is a green text within a blue field, the data is based on assumed or default values which can be verified and changed if inaccurate. For example, the production values here. So these production values are based off of the API numbers right here. So for the reporting period, however long that period is, the production data from WOGCC will be summed up for all these API numbers, or just for one if there's one API. And then black text within blue fields means that data came from impact. These values can be edited, updated in the workbook, but they will also need to be updated in impact to reflect the correct data. So one example here is the company EU description. These can be updated, but once again, these came from impact, so if you want these changes to be permanent with reoccurring workbooks, the impact profile will need to be updated. All right, so let's go over the facility summary sheet. So first, ensure that cells D2 and D4 up here and G2 and G4 reflect the correct company and reporting period. Then please check that all API numbers are accounted for under column D right here. And only facilities designated in impact as single well or pad/central gathering should have API numbers associated. The API number for a single well routed to pad/central gathering should be associated with the corresponding pad/central gathering facility. Then check that rows E through G accurately reflect the correct location of each facility. So this is important because it gives us our ambient data here, and so we pull from the nearest ambient locations that collect weather data, and then we have the minimum and maximum temperatures, average pressure, and then daily solar insolation, and the average wind speed. These are all important when running the ProMax models for the tanks and the DHIs. Then populate the production material throughputs for each facility under columns H through J, if these were not already populated with the API numbers. This data will be pre-populated, so if you have the API number, but if you have a confidential well, it will not be populated. If the API number field is blank, not all APIs were accounted for, or some of the wells are considered confidential, the production values for these facilities will need to be entered manually. Then the API gravity under column K is the average of all non-zero values for the wells associated with that facility in WOGCC. This is used to determine if the oil is considered light or heavy. If left blank, the division will assume light oil. Ensure that column L has the correct production / operating days for each facility. It is possible to have production / operating days with no production or material throughput, but it is not possible to have a production material throughput with no production or operating days. And then columns N through R pull ambient data from the closest monitoring sites, like I had said before. So once again, make sure that your facility locations are correct. And then columns S through Z right here are used to calculate flash emissions for both the produced water and oil / condensate tanks. If there were no tanks with throughputs, these cells for the facilities can be left blank. Otherwise, the pressure and temperature at the separator are required. If there is no separator, the pressure and temperature at the wellhead is required. The temperature and pressures are assumed parameters for the light or liquid right before it enters the tank. And then ensure that the facility contact information under AA through AC are correct. And then to the contact sheet. So this is blank because it's an example one that we're using, but these should be populated with some contacts. So verify that all the emission inventory and environmental contacts are accurately represented. If contact information is updated, please change column A to say yes. And on to the extended hydrocarbon analyses. Some facilities may already have these analyses pre-populated based on the well location, or if it is specified on the facility in impact. The division has a generic hydrocarbon analyses for different regions throughout the state based on the average of a group samples that were similar in composition within a specific region. These analyses can be overwritten if the company has more accurate data. These analyses can also be used for other facilities that are not pre-populated. The hydrocarbon analyses are used to calculate emissions for several different types of emission units. So first we'll go over the gas analyses. These are columns G through AL. So I will scroll all the way through. And it is used to calculate emissions from glycol dehydrators, desiccant dehydrators, pneumatics, flares, fugitives from gas components, and venting. It is also used to calculate emissions from venting or flaring associated with pigging, blowdowns, workovers, and completions. So if you have any of those emission units that operated during the reporting period, we will need a gas analysis. And then the oil hydrocarbon analysis, which is AM through BT, is used to calculate emissions from oil or condensate tanks and fugitives from oil components. So once again, if you have any of those emission units, please fill this section out. And then the produced water analyses. So these are cells BU through DB, and it is used to calculate emissions from produced water tanks and produced water fugitive components. All right, so on to the engine sheet. So for every engine that operated, please provide the nameplate or site rating. These are columns I and J, fuel type in column K, and hours operated in column L. Fuel consumption in column M, and fuel heat content in column N. The site rating takes precedence over the nameplate rating when calculating emissions. Please do not add units or measure to any of these columns. The fuel consumption and fuel heat content units are based on the type of fuel used. So the types of fuel that we may have used, and these are based off of what the emission unit represents an impact, are gas, process gas, natural gas, field gas, pipeline grade natural gas, and those will be in 1,000 cubic feet. And then gasoline, liquefied petroleum gas, or LPG, distillate oil, or diesel, refinery feed, crude oil, and refinery crude feed will be in gallons. So depending on the units or the type of fuel, you'll need to accommodate those specific units for it. Emission factors for engines can be handled in 3 different ways. The division only needs one factor for each pollutant. So we have throughput based right here, and then we have the grams per horsepower hour here, and at the end we have pounds per hour. So if multiple factors exist for a single pollutant, stack test data takes priority over manufacturer data, and the manufacturer data takes priority over the throughput-based factors. Throughput-based factors, columns O through AD, may already be pre-populated with general throughput-based factors based on the engine's source classification code and EPA's WebFire database. Please do not delete these values unless more accurate throughput factors are available. Some of the WebFire factors use the fuel heat content to determine the emissions. And then the manufacturer factors, which are the gram per horsepower hour, columns AE through AT, can be populated with manufacturer emission factors in grams per horsepower hour. And then the stack test factors, columns AU through BJ, can be populated with stack test data. At a minimum, please provide emission factors for PM, CO, NOx, SO2, and VOCs, and formaldehyde. Please provide data for all other HAPs if available, hazardous air pollutants. If it is reasonable to not have a pollutant produced by an engine, such as ammonia from natural gas engines, entering 0 for the pollutant is acceptable. Onto the heater sheet. So columns H through J are pre-populated with impact data. Please ensure that these columns are correct and make any necessary changes. Populate column A with K with the hours that the heater operated. Column L will automatically calculate fuel consumption based on the heat input rating, heat content, and hours operated. Column N can be populated with the fuel sulfur content. If it is left blank, the gas hydrocarbon analyses will be used to determine the sulfur content if the fuel type is gas, process gas, natural gas, or field gas. Then the tanks tab. So Ensure that all tank types under column I is correct. There is a drop-down menu with 4 tank options. So we have oil, water, methanol, or other. And condensate is considered light oil. So if it's a condensate tank, please put oil. Ensure that the tank capacity under column K is correct. If there is more than one tank under a single row, do not add the tank capacities together. The division will account for multiple tanks on one row. So for example, if one row has, say, this said 3, right here, 4 400-barrel condensate tanks. The division will manually change the tank quantity under column AM to 4. So one more over from here. And so this will say 400 because these are 400-barrel condensate tanks, but we will account for 4 of them. And then verify the assumed parameters under columns O through AE. Column Y should be blank if the roof type under column V is cone, and column Z should be blank if the roof type is dome. The values in columns AC and AD are pulled from the ambient data from the facility on the facility summary sheet. So this had to do with our ambient temperature and pressures for that specific area where this facility is located. And then the tank throughput under column AF is pulled from the production values under columns I or J on the facility summary sheet. So columns I through J on this sheet right here are the oil/condensate or water. And if there's more than one oil or condensate or produced water tank, the throughputs will be evenly distributed among the tanks at the facility. So for example, if the facility has a condensate throughput of 100 barrels with 2 condensate tanks, each tank would have a throughput of 50 barrels. These values can be changed if the assumptions are incorrect, so you can manually change any of these. The tank operating hours under column AG, right here, is pulled from the facility production days under column L on the facility summary sheet. So right here. These can be updated as well if they need to be. Ensure that columns HA through AL are correct. If columns HA or HL do not have the correct controls, please change in the workbook and update the emission unit and the impact profile to reflect the correct data. So if the tank is controlled by a flare and impact, we're going to list it as a flare here, but you can update it to a VRU or none, and we would like to get the facility profile updated as well. So in future iterations of the workbook, those will come through as the accurate controls. Now this is our glycol dehydrator diagram. This sheet displays the glycol dehydrator flow sheet used in Promax to calculate the emissions. So please fill out the parameters on the glycol dehydrator sheet accordingly. Now onto the glycol dehydrator sheet. Verify the values in column H and I. This data is pulled from the impact profile. If it is incorrect, please change in the workbook and update the emission unit in the impact profile to reflect the correct data. Ensure that the hours operated in column J and the actual throughput under column R or M are correct for each glycol dehydration unit. The hours operated are pulled from column L on the facility summary sheet, and the throughputs are pulled from column H on the facility summary sheet, which is the gas throughput for that facility. And once again, just like the tanks, if there are more than one glycol dehydration units, the gas throughputs will be evenly distributed among the dehydration units at that facility. Now, verify the assumptions made under columns K, L, and N for the feed gas conditions. Then verify the glycol assumptions under O through U. That's right here. And verify the glycol contactor assumptions under columns V through X. Then verify the glycol flash tank assumptions under columns Y through AC. If there is no flash tank, enter 0 in column Y. Then we will want to verify the regenerator assumptions under columns AD through AK. And finally, please verify the BTEX condenser assumptions under columns AL through AP. If there is no BTEX condenser, enter 0 in column AL. Now the desiccant dehydrators. We don't receive many of these, so this probably doesn't apply to most people, but please review all assumptions under columns H through M and O through Q. If there were no openings during the reporting period under column N, the emissions will automatically be calculated to 0. Add control information in columns O through Q. If a flare is controlling the desiccant dehydrator during the openings, vent gas heat content under column Q is required. And pneumatics. So the pneumatic sheet ensures that each pneumatic device is properly labeled as a controller or pump under column H. If any of the pneumatics are labeled incorrectly, please notify the emission inventory section. The impact profile will need to be updated and a new version of the workbook will be generated with the correct data. Ensure that the bleed rate per unit and number of pneumatic devices under columns I and J are correct. If either the bleed rate or number of devices are incorrect, please update the column in the workbook and update the emission unit in the impact profile to reflect the correct numbers. There are 3 types of pneumatic devices: pumps, intermittent controllers, and continuous controllers. The continuous controllers do not have bleed rates and impacts, so the bleed rate will need to be manually added to column I. The hours operated under column K are pulled from column L on the facility summary sheet. Please revise these as needed. So this is just the facility operating hours. Check column L to ensure that the pneumatic device or pneumatics have the appropriate controls. If any of the pneumatics have incorrect controls, please change in the workbook and update the emission unit in the impact profile to reflect the correct controls. If pneumatics are controlled and the control device had any downtime while the pneumatics were running, please populate column M accordingly. If the pneumatics are controlled by a flare, please add the vent gas heat content under column N. All right, and the flare sheet. For flares, the division only accounts for the emissions from the pilot gas burned. All other emissions coming off a flare are associated with the emission unit being controlled by said flare. So for example, separator gas routed to a flare should be reported under the venting emissions. Populate column H with the pilot gas volume in cubic feet per minute for each flare. This column may already be populated if the emission unit in impact has a pilot gas volume. If so, please verify these values. Ensure that the hours operated under column I is correct. These values are pulled from column L on the facility summary sheet. They can be overwritten if the flare did not operate during the entire production period. The pilot gas consumed under column J may already be populated if column H and I have values when the workbook is received. If column H and I have values, please verify column J, and the formula for column J is this right here. So if it's missing, you can add this formula to that column and it will calculate the pilot gas accordingly. And populate column K and L with the appropriate heat content and sulfur content. If column L is left blank, the gas hydrocarbon analyses will be used to determine sulfur content. All right, on to fugitives. All facilities will have at least one fugitive emission unit associated with it. If the fugitive ID under column C, right here, is labeled FUG00F, which we don't see here, but right there, for example, then there is no FUG emission unit for that facility in impact. Columns E, F, and H through AF will need to be populated. The division will automatically generate a new fugitive emission unit for the facility in impact with the corresponding data when the EI is uploaded to impact. If there is a fugitive emission monitoring or FEM plan, add an effective control efficiency under column H. When calculating best available control technology or BACT, the New Source Review, or NSR, uses a 50% effective control efficiency for semi-annual instrument-based monitoring and repairs, and a 60% effective control efficiency for quarterly instrument-based monitoring and repair. If a different control efficiency is used, the methodology to quantify emissions and emission reductions must be approved by the division. Portable analyzers do not qualify as instrument-based monitoring. Now, verify and or add the fugitive component count for each fugitive emission unit under columns I, right here, through AF. If the fugitive unit has a component count in the impact profile, the components will be listed in those columns. All right, venting, pigging, and blowdown sheet. Add any venting, pigging, or blowdown events that occurred during the reporting period to the venting, pigging, blowdown sheet. Populate columns I with the total number of events. Populate columns J with the total gas vented in cubic feet. And populate column K with the average event length in hours. This is the average time per event for the number of events listed in column I. If the events are controlled, please list whether or not they are controlled by a vapor recovery unit, or VRU, or a flare in column L. If any of the control devices had downtime during the venting, pigging, or blowdown event, please add the amount of control device downtime under column M. If a flare is listed as a control device, please populate column N with gas to the flare in cubic feet per hour. If unsure what to put under column N, please check our written production workbook guidance for this section. There is a formula for it, and you can use that formula and it will automatically calculate that number. If a flare is listed as a control device, please populate column O with the heat content of gas being flared in BTU per cubic feet. On to the workovers and completion sheet. So add any workovers or completion events that occurred during the reporting period to the workovers and completion sheet. Populate column I with the total number of events, column J with the total gas vented in cubic feet, and populate column K with the average event length in hours. This is the average time per event for the number of events listed in column I. If the events are controlled, please list whether or not they are controlled by a vapor recovery unit, VRU, or a flare in column L. If any of the control devices had downtime, please add the amount of time in hours under column M. If a flare is listed as a control device, please populate column N with the gas to the flare in cubic feet per hour. So that is column N. And then once again, if you're unsure how to fill out column N, there is another formula in the written guidance on our website that will show you how to calculate that. And then if a flare is listed as a control device, please populate column O with the heat content of gas being flared in BTU per cubic feet. If engines were used during these events, please populate columns P through S with the appropriate data. If the engines are diesel powered, column R should be in gallons. If the engines are natural gas powered, column R should be in 1,000 cubic feet. Do not include units of measure. Add engine emissions to rows T through AI. At a minimum, please provide PM, CO, NOx, SO2, and VOCs, and formaldehyde. Please provide data for other HAPs if available. These values are the total pounds of each pollutant and must be calculated by the company. On to truck loading. So the truck loading emissions are calculated in PROMAX based on data under columns A, J through AL on the tank sheet. So we'll go back to the tank sheet to show you that. And that is AJ through AL right here. All facilities will have at least one load-out emission unit associated with it. if the loadout ID under column C is labeled load or LUD00L, then there is no LUD emission unit for that facility in impact. The division will automatically generate a new loadout emission unit for the facility in impact with the corresponding data when the EI is uploaded to impact. So let's see if there are any under here. Right here, there's an example of one. If there is no throughput associated with a LUD00L unit, the unit will not be created in impact. And then ensure that columns I through K are populated correctly. The hours operated under column J has no effect on the loadout emissions as long as it is greater than 0. If the hours are zeroed out, the loadout emissions will be zeroed out as well. Right, and then non-road mobile. So non-road mobile sources include but are not limited to construction equipment used for road, pad, and pipeline construction, snow removal, and rig moves. If non-road mobile activities were not performed during the inventory time frame, please indicate as such in the space provided at the top of the non-road mobile sheet. Right here. Enter the date, legal location, county, and operating hours of non-road mobile activities under columns A through H. Enter the emissions for each activity in pounds per hour under columns I through O. And enter the operation time or type in column W. If additional rows are needed, you can scroll down to the bottom where the total is located right here, and just right-click the column or row right above it and click Insert, and you can add an additional row or as many as you need. The formula from the rows above should populate the newly added rows due to Microsoft Excel table features. If not, please contact the emission inventory section. All right, and then on-road mobile. On-road mobile sources include but are not limited to liquid haul trucks, operator vehicles, and other vehicles. If no on-road mobile activities occurred during the inventory time frame, please indicate as such in the space provided at the top of the sheet right here. Enter the total miles traveled, average weekday miles traveled, average weekend miles traveled, and average vehicle speed for each type of vehicle. That would be light-duty gasoline, heavy-duty gasoline, light-duty diesel, and heavy-duty diesel in each county. Note that counties in this table are organized by the division's compliance district. So as you can see, District 1 right here has their counties, and the same with the other districts as well. And then last but not least, we'll go back to the operator comment sheet, which is the very first sheet on this workbook. Please use this sheet to make any comments about the emission inventory. This can be used to inform the division of any abnormalities that might be found in the inventory. Examples include a reported production site was drilled in the period or reporting inventory year but not completed during the same year. Tank emissions for production sites will be reported as liquid gathering stations instead of this inventory form. A reported well did not operate but did have other operating equipment with emissions. A reported production site contains emission-producing equipment that is operated and or reported by another company and thus not included in this inventory form. For example, if a separate company operates the dehydration equipment at a well or pad site. The rationale, another example would be the rationale for using emission factor groups that differ from the emission factor groups that the wells belong to. Do not use the operator comment sheet to report any emission values for sources that are not covered by the other calculation sheets. Any missing emission units will need to be added to the impact profiles, and then a new workbook will be generated. So please reach out to our group. We can get those units added, and then we'll send you a new workbook with the correct units for them.